works. Now, most of you might be thinking, usually this is how calling works, right? You have two phones, and when you call the other guy, right, your call is connected with the other guy directly, right? It should be something like this, right? Okay, but actually that's not the case. Okay, why? Because the thing is that if you're calling that other person, even if you know their phone number, you call them, how does your phone know the sort of like the location of the other person you call? I mean, even if there's like, whatever calling infrastructure, talking about things like landline and all that. So you still need like, maybe like looking at 20, 30 years ago, I'm not sure if any of you know, like let's say if you're using a landline you call, right? There's always this phone operator that helps to like flick this buttons up to put people around. Okay, those are the olden days. But the latest days is of course more recently, if you're using a landline you call, right? You have a cell tower or you have a telco. Or you have some infra that helps you do that connection seamlessly. So it almost looks like magic. When you're calling someone, it looks like you're almost doing it indirectly. Okay, and this same logic applies to if you're going to build your own calling system as well, which is that you need some sort of backend system to be able to do this exchange of information to allow you to do that phone call before the actual phone call happens. Okay, so this is where the some sort of backend server might come in when we are building this solution. Okay. And we are also going to make use of a popular technology, which is WebRTC. RTC stands for real-time communication. And using WebRTC, you should be able to use it to it enables web applications to be able to stream audio as well as video streams. Okay, so if you're able to tap on this technology properly, right, you should, strictly speaking, be able to connect two web applications from two different users into different networks. Okay, and this extends into, let's say, if you want to use it on Android, iOS, there's also WebRTC SDKs for those platforms as well. Okay, so technically speaking, you can connect mobile phone to web, vice versa, or Android to iOS. Okay, so that's the basis of, as I was thinking about this, that's the basis of my solution on how I'm going to build it. Now, again, talk is cheap. Like, how exactly are we going to build the components of the solution, and create a proper working product? Okay. To do this, I like to propose a problem statement first and break it down to multiple components and show you what you need to do to get to the solution. Okay. So firstly, we know that as part of this mysterious company that's like the G, right, that I'm looking for, they have a super app mobile application. So we need to build a calling function in this mobile application. And the thing is, as I was thinking about myself building this POC, right, I mean, there's no point going all out and building a mobile application. I'm sure for those who have worked on both mobile and web before, mobile is a little bit hard to POC, it's a bit more slower. It's easier just to bring up a web application and just build it. Either way, as long as the POC works, you can just move it across different devices or different platforms. Okay, so I reduced down my problem. Let's just solve it for a web application first. Okay, and part of this web application, I know that I need some sort of front end. The front end itself needs to use WebRTC, as I mentioned earlier on. This is called browser technology, in order to be able to make this WebRTC call. Okay, and as part of this web application, I also need to build in the logic where this front end application needs to both act as a caller as well as a callee. Because as a caller, right, if I'm making a phone call to another user, it needs to know how it can call the instance of itself. So it has to also be able to act like a caller and a callee, similar to how your phone behaves today. Beyond that, we also need that backend server, as I mentioned earlier on, right, for the data exchange. But there are also certain features you need to build this service. Firstly, you need to build in an identification functionality. Why? If you look at our current traditional way of communicating, right, we need to use like some sort of phone number to call the other person. So that's kind of like the ID. In the same way, if I'm saying I want to use the internet, I take my phone, I call another mysterious person, you kind of need to let whatever systems know what person you're calling to, what's the ID you identify them by. Of course, this is a very simple problem to solve. Any login system will work for this today. So if you just use that, or maybe you want to create like some sort of pseudo number like ID, you can also do that as well. Okay, but the more important one is the requirement to build in the data negotiation functionality. Okay, so this is what's required in order to exchange the WebRTC information between your two phone clients or browser clients in order to do that connection and build that WebRTC connection for the call later on. Okay, so you need your backend server to be able to do this. But here's a tricky part. This is where one of the problems come in, which is that when we talk about building front-end service, back-end APIs, we think about HTTP, right? It's a push from the front-end to the back-end. But here's the thing. In order to do data negotiation properly, I need, let's say, like some user A to call the backend first. Then backend needs to now talk to user B and then ask user B to get the information. But if user B hasn't made the request to me, right? How do I talk to user B and get them to push their information to me? Some of the more observant people might already be thinking about one or two solutions in the head. Like there's a couple. I think there's maybe up to at least three that I know of. And WebSockets will be one of the more popular and easier solutions to adopt. Get your backend to service the WebSocket server, and then get your front end to be able to connect to the WebSocket client, so that your backend server can also do that push to user B and force user B to return some sort of response back. Whether they want to connect or not doesn't matter, but at least you need to be able to connect with the second user. Okay, and by doing this, right, you should be able to have your entire WebRTC calling solution. Okay, so like I said, this is a whole solution. And here's how the simplified infrastructure diagram will look like. Some front-end application, like I said, it needs to have the WebRTC client capability to be able to call instances of itself, and a backend application with a WebSocket server. Okay, let's talk about the tooling that you need to build this solution. Okay, for front-end, I decided to go with Next.js. I like to think that Next.js is a very popular front-end solution. You see some people smiling, so I'm going to think that's a yes. And I think comparing to the more heavyweight frameworks, I would say definitely, like let's say if I were to use, I don't know, create React app, I'm not sure if anyone uses that today together with React Router. I would say that's a lot more tougher if I want to just create a very easy static web application. With Next.js, I can just do it, within let's say like 10 minutes. I just need to get familiarized with some of the configuration, even if I've forgotten about it. Okay, so yeah, we went with Next.js for front end. For backend, it was a little bit of a, I wouldn't say confusion, but more like a conflict with myself, because this company I work for, right, their backend that they're using is mostly in Go. So I was thinking, maybe I should use Go. But then again, this is just a POC. If I'm doing this as a startup, if I'm building a single product, it makes the most sense to just build both the front end and back end in one single language. And as a POC, I think those who might have used Go before, you might also agree that it's really hard to build like a POC in Go. Like it takes some time, there's always like all these hoops to jump through. And also with the open source libraries that's available, for JavaScript, it's actually a lot more as compared to Go today. Yeah. So I decided to go with Node.js in the backend instead. Okay. And then for hosting the application, I went with Google Cloud. That's it. I'm not here to sell Google Cloud. I'm not a salesperson, don't worry. So if you want to use like AWS, you want to use Azure, it's okay. Like I'll show the diagram later on, which is all of the different Google Cloud tech. But if you want to discuss later on, what's the equivalent in other cloud providers, happy to have a conversation later on. Okay, so let's go back into our infrastructure diagram here, and let's look at translating some of these parts of our system into the tools that we see earlier on. So firstly, you can see that very nice boundary of Google Cloud Platform, where both your front end and back end application to be under. Okay, and first let's look at replacing our front end application. So I want this to be the next JS web application, as mentioned. But one special thing you might see here is that I'm using cloud storage. Okay, so the equivalent of this in AWS, for those who are not familiar with Google Cloud, is S3. So it's a bucket. It's not a virtual machine. It's not even serverless. Like, how do you host a server in there? Okay, so interesting thing here is that it's because I decided to go with a static web application rather than running a server. Just build off the static web files and just run from the bucket. And the reason for doing that is actually very simple. Because I don't really need server-side render, I just want to leverage on the pros where if I want this to be really infinitely scalable, right? Just use the bucket. Your SLA is depending on the bucket's SLA itself. Yeah. So, and also for a POC, it's just very easy for me, just set it up and get it working from there. Okay. Then moving on to the backend. Okay, backend definitely we can't use the same solution. So backend itself, I decided to go with another simple solution, which is use serverless. So this is Cloud Run inside Google Cloud. Essentially what it needs is a Docker image that you can use to spin up a container inside the cloud environment. Okay, and with a few simple configurations, you should be able to set it up to scale how much you as much as you need. Okay. And another great thing I love about using Cloud Run as part of the serverless, and this is the same for other cloud providers as well. Why I would recommend for people, right, to use serverless, especially if they're experimenting, is that you can scale down to zero. If you're just working on your own side project, it's so great to let it scale down to zero and you don't pay a single cent for your server resources. Unlike if let's say you bring up your own like compute engine, virtual machines, or if you bring up your own Kubernetes engine cluster, right? Then essentially you still need that virtual machine to be alive. So it can be a bit of a problem when you have to get paid that money to sustain that server cost. Okay, so essentially simplified solution, this is how it looks like. Some of you might be thinking in your mind, wow, I have to go to production already. So simple. Let me scare you. So much. Okay, so essentially I would say if you, of course that's just a small microism of like how it looks like, a snapshot of it. I mean in the small time frame of I think I have half an hour for this, I can't really go too deep. But you can do definitely a lot more with building an entire fully fledged calling system using any of the cloud providers. So some of the components like the web app and the server-side cloud run, right, it's just one small part as you see with that. It's like maybe just 20% of this. Yeah. So there's also a lot more functionalities. Yeah. But again, I can't go too deep into this. So finally later on we can discuss about this if you are interested. Okay, I say it's demo, but unfortunately, like I presented in this place before, there's some issues with the Wi-Fi and me being able to do the demo properly. So I'm going to show you a video. Luckily, I took a video. Okay, so
oh, proof of concept. Can you say something? Why is it a Pikachu?
This from the room itself.
Oh.
Okay, bye-bye.
Presenting it.
Is your laptop having?
I turned it on, like, you give a feedback too.
Oh, I can just do this.
Okay, about this. Let's turn off our mics first.
Okay.
Then I'll make this super loud. Maybe you turn off yours. Then I'll use my speakers for here.
Okay.
Yeah. Okay, let's try it again. It's just 17 seconds.
Oh, proof of concept. Can you say something? Why is it a Pikachu?
You can change.
Okay, bye-bye.
Okay, so maybe let me describe a bit of a video if it looks very confusing. That was my computer. My wife was holding my phone in our bedroom, and she was basically just showing that video call from our study room to our bedroom, doing that call over there. So a few things we can learn from this. Yeah, definitely with what I've shared with you so far, we can build like some sort of, at least in staging, like some sort of workable calling solution. Of course, there's still some things that you need to lift it up to make it production grade. And also another thing that I learned on that day itself is, yeah, you can also get your spouse to help you invest with your own private projects, but you own her a little bit, like, she got a bit angry with me, so I had to bring her out and eat good stuff after that. Okay, let's go to the next slide. All right, so hope you guys were convinced by the demo itself and this thing works. Now, I want to share with you some WebRTC tips if you are here today to maybe learn more about like WebRTC communication and some things I learned along the way. Okay, so first thing I like to say is that WebRTC is really tough. It's understanding it was crazy. Like for example, just understanding how it works, you can see this very in-depth explanation that today I definitely won't be able to explain to you. I'll share these links later. But there's a lot of documentation online to augment information over here, so you can definitely look up for those to understand how WebRTC works. Again, I'll share the slides later, so if you want, you can just the links, everything will be there later as well. Okay, but the thing is, in terms of just implementing the flow, I did wanted to at least create some sort of UML diagram, which again, this slides will be shown later or shared later, so that you can use this if you want to sort of replicate it and build it for your own project. Okay, so essentially it's just a very simple way to show, initializing a first user, second user with a WebSocket service, and then allowing that WebRTC communication to take place. And once that's done, you should be able to do that phone call between two of the users, as long as one of them initiate the call to another person. Okay, and then one last tip over here is that the samples page for WebRTC, there's actually this GitHub pages page for samples in WebRTC. It's a bit of a cheat when you're running this because you're kind of like doing everything on one device. If you test it, right, you actually see that you're both the caller and callee. So it's a bit weird where you stream your feed and then you see yourself as both the caller and callee. But it's still a very good way for you to get started if you're looking at building a calling solution for yourself, testing web-based calling technology. Okay, and finally, I'd like to share some mistakes I made. So I mentioned that I presented in this place before. It was for Geekan last year, and the presentation venue was actually upstairs. It's actually also part of the reason why the demo didn't work today with the current Wi-Fi network. So here's the thing. I presented this diagram to you just now, and I say that this should work. Now the interesting thing is that this is only 1/3 of the whole calling solution, and actually what our vendors were doing were actually a lot more than this. So here's the dilemma. The thing is that when you do a WebRTC call, it's actually between two different users talking to each other. But what we built so far is only that signaling server for them in exchanging their information. But what if in the case of these two peers, right, these two users of phones, right, do they know each other's public IP address, be able to talk to each other? Okay, here's the thing. With the setup I built just now, right, if I don't add any additional thing on there, right, there's actually something else I add in here. But if I didn't tell you there's an additional thing needed there, right, this call wouldn't happen if your two devices are not on the same network. Okay. So you actually need this thing called the stun server. So using a stun server, right, they actually exchange the public IP information of both of your devices so that your devices know that if they're calling the other person, it's not only just the WebRTC communication protocol and information, but also knowing where you send that to, knowing the public IP address of other phone. Okay. And here's the interesting thing. This is only 2/3 of the solution. There's still 1/3 missing, because in present day infrastructure and network settings, there's also this other pesky thing. It's not pesky, it's more security. It's called firewall. So this is also another problematic thing that is not problematic, but rather it's problematic your implementation, which is that with a firewall, right? Sometimes your firewall might prevent you from accessing certain services on the internet. And just unluckily, maybe the other person's IP address fall under the range that was blacklisted. Okay, so the problem is that even if you know the other person's IP address, it may not be a guarantee that you can do this call. Okay, and to solve this, so this stun server, right, is actually just a proxy in simple terms. It allows one of the peers to be able to make a call through this stun server as a proxy to the other person. So you can think of it as instead of the call going from one phone to the other phone, right, it's more like from phone A to stun server to phone B. Okay. And fortunately, if you want to implement this entire call setup yourself, you can actually use this open source library, the intern server, which acts as both intern and stun server. Okay. So this is something that you can use if you want to build your own fully fledged calling solution. Okay. And last but not least, back to this entire infrastructure diagram, actually it's already listed here. So if you want to build an entire production grade setup, technically speaking, you can host part of this entire intern server as your virtual machines or cloud Kubernetes, to be able to interface with your current calling solutions and make it work. And with that, we've reached the end of the entire sharing over here. I hope you guys enjoy what I've shared over here. Hopefully it was interesting. I just want to point out a little bit that at the bottom there, of course I know I put the social media profiles there, but if you want to try a fun way to get my social profile, just approach me later, I'll show you a fun way to do it. Okay, anyway, thank you.
Anyone have questions? Okay.
You come to the console, does it handle the client behind the LAN?
So you come here.
If the client is behind LAN, does the transfer handle that as well?
It is behind the net. That's interesting because if you're talking about net gateway, right? That's not like a
yeah, let's say like it's behind like a private IP range. The client has like a private IP range. There's no port forwarding or whatsoever at the net. Yeah.
I'm gonna guess. Okay, I'm gonna guess it's probably not gonna work because as you say, for the net gateway you'll get it only behind one single IP address for every single machine in your cluster. But calling solution like this is more like for two users, right? Especially like public usage, for example, for your phones, your browser or browser. I think if you're looking at net gateway, usually you're talking about a bunch of servers inside your own network, right? You're trying to mask that.
So my question is the transfer will actually help it to mitigate it or
the transfer there's the process or does it not that's more of the question.
Okay, can come again. Like the answer in terms of the address service.
The TUR in the transfer, yeah.
No, I would still say that shouldn't work because in the end that turn server still needs to know the party address.
Oh, okay.
Okay. So it's not functional as long as the address itself is not completed. Yeah.
Okay. You got it right.
Yeah.
Okay,
Thank
nice.
you.
So anyone else have questions?
So this is one-to-one, right? Is it possible to do like a like one to a few people?
Challenging question, Roger. You're killing me here. Theoretically speaking, it should be, but don't hold me to that because I've read about it that you should be able to do like what do you call it, multi-participants inside the WebRTC call. I haven't implemented to that, so I can't give you that guarantee. Yeah, but it should be possible. Yeah.
Okay. Thank you. Thank you for sharing. Oh, okay. Sorry. It's okay. Don't worry.
Thank you. I have some question because I have tried WebRTC before. Yeah, we see that we can use it for like a media, big media like video and audio. But how about if we want to like, just want to transfer text message like by peer-to-peer, maybe sending a JSON across device?
The question is possible. Okay, I've not tried to that extent, but I'll say actually the question of why, because WebRTC itself, we are leveraging on its APIs, good horse right way to create that stream in between two devices for audio and video. I think to hack it towards sending a non-audio, non-video payload seems a bit odd. I would say definitely it's possible, definitely can hack through and take out away. But probably what you're looking for seems to be more WebSocket. Like I think you're just doing that bi-directional communication to send that payload back and forth. But of course, that will still go through like some proxy server. If you are solving for direct user-to-user communication, I'm gonna say it's possible, but it probably needs a little bit of hacking through. I don't think I've seen anyone done that before.
Thank you.
Thank you. Okay. Have you a question? Okay. Anyone else have questions? Okay. Thank you very much for sharing. And before I send you to Pisa, who's order? Okay. Take your order vessel later from me. And I put Pisa on the table. You can just go grab Pisa. We will
tell you about because this was using WebGL. We had some people talking about it earlier, and WebRTC. We also had this mentioned. So this was an app where people connect with their phones and they start the devices communicate with each other through WebRTC and then drive the visuals. This was a group show with my friend Gaetan Boisson, who's right here. And Gaetan is also a creative technologist, and he has a show at the moment at Anes Yadav's gallery in Weiyuan Liu. So if you want to check it out, I think he's using generative AI and large language models. The show is called Paratext, and there's an artist talk at 2 p.m. this Saturday. So this is my relationship to technology. And then I was working at NUS and working, as I said, on making online platforms, web projects to showcase scholarship and make the best effort to make them sustainable. So I tried a lot of approaches, and while I was suffering at the end of three, I found to create experiences showcasing scientific data, scholarship at NUS. And at the time, I was really happy with Gatsby because it had this GraphQL layer to fetch data from different parts, and I thought this was really amazing. I don't think this way anymore. I found a much better option. So my tools of choice today are Svelte and Astro to replace React, and Astro to replace Gatsby. We will see later how Astro replaced this GraphQL layer with something that is so much more simple and so much more efficient. Now, maps. So we have all been using maps a lot and every day. So maybe it seems like a very obvious thing and it shouldn't be too difficult to do a map. But if you've read XKCD before, and you certainly have, you might have an idea of why it's complicated. So the big news first is that the Earth is not flat. And it's not even a sphere. It looks more like this. So this is actual data, elevation data from the Earth, but magnified 10,000 times, so that we really see how unequal and uneven the surface is. So we are working with an object that looks a bit like this, but we need to have this projected on a flat surface because our screens are flat and paper is flat. And this is how we actually experience the world. That's why people believe it was flat. If I move 1 meter this way, I don't feel the curvature of the Earth, and I don't fall unless I'm drunk. And so this actually means so much more than we might instinctively think. So the conventions you are familiar with, the conventions we're all familiar with, something called WGS84. That's if I want to show off and don't say longitude, latitude, I will say WGS84. So that's what we all know, these angles, that many degrees north, that many degrees east. But when I walk 1 meter, the notion of degrees is clearly not here. And because of the shape of the Earth, actually this 1 meter, the way this relates to the degrees with the center of the Earth, that kind of depends on your location. So things get really, really hairy. So we have a lot of ways to handle this in our software. And we have essentially 2 types of data when dealing with geospatial data. One is what we call vector data, and the other is raster data. And if it clicks in your head that there's a parallel with computer graphics, then you're on the right track. When we handle vector data, we'll have a list of coordinates. So here we can use longitude and latitude, and we'll be able to draw shapes like polygons or lines. And when we deal with raster data, so this vector data is probably very easy to grasp. It's very obvious to think like, oh yeah, we have these coordinates and we draw shapes. We have something called raster data, and it will look like this. And here we also have coordinates, and we have a grid with values. And these values could be anything. So think that if you're doing a geographic project and you're taking measurements across the city or whatever, you want to do exactly this, like stride across the city 10 meters by 10 meters and take a measurement at every spot on the grid. And then you end up with a raster of values. but your coordinates in your raster cannot be angular coordinates because you have something flat, rectangular, and so you need a projection. So this is the two kinds of data we will work with. But then I was telling you we're working with historical maps and not measurements. So what happens here is that when you have raster data, you can have multiple channels. You can do one measurement for the pollution, one measurement will be the altitude, etc. So what we are doing when we do this kind of project is that we have 3 channels in our raster data, and these channels are red, green, and blue. So actually we have an image. The file formats we're using for geospatial data are images, TIFF images. Now these files will end up being absolutely massive, because if you take 1 pixel for every 10 by 10 meters square in your city, you're going to have a lot of pixels. And if you're doing actual measurements, you cannot compress your image because any variation in the measurement will screw your data. So typically raster data will become huge and you will not be able to display it. So what we do is that we have what we call tile pyramids. At the highest resolution where you have the full data, you're going to split your image in smaller squares called tiles, and you'll be able to load them separately. And you'll have a pyramid of this smaller and smaller resolution until you have one tile that covers the whole area at a very low resolution. This is a screenshot from QGIS, the most important open source software for JS data. And this is just an excerpt of the list of file formats for raster data only. So it's a lot of different formats. So with everything that we say now, I'm sure you understand that serving geospatial data sounds pretty complicated. It's not going to be that straightforward. So this is what the typical stack would look like. If you're going open source, you can use this kind of software, set up your Linux server, set up the geospatial server, and these software will take care of projecting the data, tiling it properly, answering the queries from the client, sending specifically the parts that are required. And this is starting to look a lot like this, which is not what we wanted. So that was the whole conundrum. If we have this, then we cannot have a sustainable solution because we need to maintain all this software. So what can we do to solve this problem? The solution was convention over configuration. If we decide on one specific projection and one system, then we could pre-generate all these tiles. We don't need to have a server that does the work live. So instead of having the one original data and a server that takes care of translating at each request, we will just say that, well, our project will work with the Mercator projection and these systems, and this is what we have. So this screenshot is very small. I don't know if you can see this. So this is the Istanbul Urban Database, another website that shows historical maps. And here I'm looking at the network tab of the DevTools. This is one request for one tile, and the server is Amazon S3, very small. But what they did here was that they pre-generated all the tiles of all the pyramids for each of their maps, and they are just storing this on S3. So this is essentially a pretty good solution already. You won't have to maintain this heavy server, but you have this really deep and complicated file structure with all your files in subfolders. So one for the X coordinates, Y coordinates, and the zoom. All these 3 dimensions to get all the files. So it can work statically, but you will be managing thousands and thousands and thousands of files on your storage. Thankfully, geospatial engineers have been thinking of the problem, and they found very interesting solutions. My solution of choice, what I liked best, was what they call optimized geotips. So this relies on HTTP range requests. Everyone's familiar with HTTP, I assume, but the idea is when you send an HTTP request with a branch header, you can specify the bytes you want from the file. And so the idea was we're going to have one big file with all of our files, and this file has a specific layout so that you first make a request to the very specific header first part of the image, which sends you an index of everything it holds, and then the client will know where it can fetch different tiles from the image. So there will be no need to ask the server to do any work, because the client will fetch the metadata, know where to fetch the different tiles, and then do the whole math itself to fetch the specific tiles that it needs to display. I see some people being confused. I think all right. Okay. So this is what we chose. And then came maybe the hardest part of the project. We need to choose a JavaScript library. So what are we going to do? Well, the landscape for JS in JavaScript has quite a few options, and the most famous is Leaflet. I see some people nodding. Well, I don't like Leaflet. I find it a bit dated. It does weird things with like global window, just no. But also it just does not support cloud alternatives out of the box. So I looked at other options. The next other options is Maplib or Mapbox.jl, if you know. This is a very popular option. It's very user-friendly, and it's become very fashionable because it uses WebGL, and you can have 3D views, elevation, show buildings, all this. It's very fancy. But it does things that I find a bit weird. So basically, the way to use it is you will write this really long JSON configuration files. It's a domain-specific language that they have. And you do things like, okay, the color of my circles, well, it will be in RGB, and my 3 channels, the first one will use get and temperature, which is the way to say that depending on the temperature, this will be your value for the red channel. I want to write code, not a configuration file like this. And lastly, well, he doesn't support cloud alternatives. So this is how I found out OpenLayers. OpenLayers is not as famous, but it's actually very popular amongst people who do geospatial data. And as I was working on this project, I met somebody, a Singaporean guy, who told me like, oh yeah, this is what we use when we go to the army. It's like, okay, so I'm pretty sure the army is very precise about what they do when they talk about geography. This is a good thing. And this one supports cloud alternatives out of the box through a dependency called geospatial.js. Okay, so now we have everything. We could build our app and just start writing JavaScript. But I did not want to just start writing JavaScript like this. I'd like to use a framework and make things a bit cleaner. So I chose Svelte. Svelte because the developer experience is just exceptional, and the community is amazing. And yeah, it's just a very, very good choice. I'm going to quickly go through how we did it, but Svelte offers a context API that will allow you to share the state from a parent component to its children component. So this is the component hierarchy we have. We have a map component at the root. It holds a base map component that will load the data from OpenStreetMap, the interface itself, and the interface will have all its features, as well as all the items that will be displayed by the map. So very quickly, here we have the root of our application. So there's a map component with the base map and the interface, and there's no notion of context here, because this happens in the first parent component for the map. This one will be creating the context. So we have a context file where we define everything here for the status of the state of our application. And then in the map component itself, we create this context that we will then share downstream with the children component. Here, what we do is when the component mounts, when the map component mounts, it will use the onMount hook from Svelte and initialize the whole map. And I have this little trick here to make sure that the children components do not get mounted before the map has been initialized. This is the base map component. So here it will be very simple. We will get the context from the context that is shared from the parent, and we'll just add the layer for OpenStreetMap. And one more svelte trick, I wanted to prefetch each map, make it feel a bit faster for the users. Do not wait for them to have clicked on the link to fetch this metadata that we need to fetch from the cloud objective. So I use the onPointer enter event, and it fires just once, so that when the user hovers over a link, we will fetch that metadata and accelerate this a little bit. And then once we have loaded, we mount the layer component itself, which triggers the load of the data. Okay, so now once again, we could feel like, well, that's it, we have everything we need. We have the whole application put together, and we could have built this with These just as a single page application, but we would be missing out on a lot of good features to make it a full application, and we would be missing out a lot on SEO. So here we chose to use Astro. So same reason, amazing developer experience, amazing community, great features. So if you don't know, Astro is a static site generator. So this is exactly what I want. Build static pages that I will put on the CDN. One feature that was really useful here is what Astro called content collection. So we organize all our maps in one of these content collections to generate all our pages. Here we have the base layout of our site. So you see the Astro syntax looks just like HTML. The only difference is that here we have a component that is not HTML, and this is our svelte component. Here is one of our pages, so we just have Markdown. For me, this was also a big selling point. I'm giving this project to librarians. If they want to edit it, I don't want them to have to touch any code. So here, the only thing they have to touch is Markdown, and the metadata looks pretty simple. So how the content collections worked. Here we have the template for our metadata pages themselves, and here we fetch with the static basket collection here each map from our content collection, and this will in turn generate one static page for our website for each. But there was one more part where we could use this content collection, and that turned out very useful. Is that if you remember, or you don't remember, I did not insist on it, but when we create this component with our maps, we pass it a prop with the maps info. I wanted to make sure that the information that is used to generate all the static pages is the same that is used to generate the interface itself and the list of maps. And this is how we did it. Using the collection, the content collection feature from Astro, I could generate both our pages and the data that is sent to the svelte component that gets integrated in our interface. So that's it. Sorry, I rushed a little bit in the end, but this is how we built this website and make sure to have a service where we offer geospatial data in a fully static way while skipping all the complexities that usually come with geospatial data. Thank you.
Okay, so we cannot have any questions because we're like 15-20 minutes late. So any questions, you can ask him in the conference. Yes, he will be there. So Singapore JS, it's a discount code, but you have to get it now. Okay, where stands in? Okay. He's gonna get his mic. So I was looking for a chatbot because my manager told me that you need to build something in AI, and it was very accidental. I found Tenzin, and I thought, so, oh, this guy is from Singapore, and I'm going to Singapore. So, okay, let me add him as a speaker. But it's his first stop ever, so he's a bit stressed. So make a big clap so he can get a bit more excited. So how many of you use React? How many of you have you built a chatbot? You know you can build a chatbot with bonnets, right? So, okay. And, oh, yes, you need to share your slides. So I can use this link. You have joined. Okay, you're a good boy. I like you. So, all right. So we're ready to go. It was the fastest. So let's do this. Okay, so, okay, what do you have for us, Clarice? So come and tell us, show us. Are you going to do it part of the talk? Okay, so you have to stay here for the next talk if you want to get some really cool stuff. So you don't leave, okay? I saw some people left, maybe they went to the toilet, but they will come back. So how many people use Angular here? Only one? I see a person wearing a t-shirt from, is it from last year? The t-shirt? Okay. I have printed 150 t-shirts this year. So whoever comes will get also a t-shirt. Are you ready? Oh, there's a problem? There's always a problem. We're developers, so we are supposed to fix the problems or create new problems. So who is the first time, who is here for the first time in Singapore? Okay. So where are you from?
Australia.
Oh, you are the one before with Australia. Where in Australia?
Melbourne.
Melbourne. Is it a Greek city?
Fantastic city.
But it's a Greek city.
Oh, great. There's lots of Greek cities.
Yeah, there's a second city outside of Greece that is the largest Greek city.
There's great Greek food, for sure.
Okay. And you look a bit Greek.
No, I'm not. I'm originally from Peru.
Oh, nice.
So, yeah.
Okay, yeah, I'm just gonna keep talking. And so, did you enjoy the pizza? Most of you, because these guys came late. So yeah,
Shall we give these things away then?
maybe, yeah, we can do that now.
So we'll start giving to the first person who has ever heard of on it.
Who has heard of bonnets?
You heard of on it?
Of course.
Yeah. Put it on the spot. Okay, you've heard of on it. You've heard of on it. So, sorry.
Oh, there.
Okay. Can you tell me one of our APIs? You already got it. You don't have to tell me.
Who has created a chatbot?
Voice over internet.
Okay, people are learning now. I like that.
So,
I mean, they need pens as well, right?
what will be the talk after? About?
So my talk after this one is about using multi-factor authentication with bondage APIs, which some people here already know what they are, and Firebase services. So I guess by the end of the talk, everyone is ready to get these because you know the code stuff. Thank you.
Who's building stuff with security? Nobody. Is your website secure?
Yes.
How do you know?
Penetration tests.
Okay. No hackers?
No.
I was in a taxi yesterday and suddenly I saw a truck. There were some people on the truck and behind the truck was saying hackers. It had a telephone number. So I saw, oh, this is where the hackers are from, Singapore. Now I know.
You're gonna use Sonar Cloud.
Sonar Cloud.
Yeah.
Oh, yes, I know Sonar Cloud. Yeah. Is it where the hackers are? No. It's just jokes, Greek jokes. So yeah, somebody asked me, how did I start CityJS? Does anybody know? Okay, so I started a meetup in London, and it's called JS Monthly. So before that, I was going to conferences, and I met a guy called Dylan Seaman. Do you know him? He's doing Halfstack. So Dylan was like TypeScript Pro. And then I met Kyle Simpson. Do you know Kyle Simpson?
Yes.
He was here last year. And so Kyle was very JavaScript Pro. And I thought, they need to come to my meetup. I want a class. I wanted two people to fight TypeScript, JavaScript. And they told me, if you want me to come to your meetup, it's too expensive. You need to make a conference. So I used to work for a university. I still work for it. It's called City University in London. So we were discussing what the name of the conference should be. And I thought, City University, CityJS. But I didn't think of doing like this crazy thing of all the cities. So here I am. What's happening, guys? I have run out of stuff to say. Okay. So yeah, the conference finishes. After the conference, Greece is playing basketball. We haven't played for like 15 or 16 years. And so after the conference, I'm staying in a television watching the game, 2 o'clock at night here. Yes. I don't know, because you need to still connect to that WeWork thing, and it's broken. The hackers from Singapore. Yeah, so let's see. Maybe you need to do a reset. Did you do a reset? You know this joke about the 3 engineers in a car? Do you know? There are 3 engineers in a car. 1 mechanical engineer, an electrical engineer, and a computer engineer. And they're driving. And the car brakes. And the electrical engineer says, it's an electrical fault. I will fix it. So he tries to fix it, he can't fix it. Then the mechanical engineer comes and says, it's a mechanical fault. I'm going to fix it. He tried to fix it, he can't fix it. Then the computer engineer comes. He says, can you please go out of your car and come back in? So yeah, this is what we're doing. We're going out and come back in to fix the problem. How many of you have you been asked to fix a printer? You don't have to do it anymore because everything is digital and we don't print. Is it working? It's when you expect not to happen, everything goes wrong. The Newton's law. You're not connected to the Wi-Fi. It's connected. So you're connected here on the screen.
Yes, all right, okay.
Okay, thank God for that. Okay. All right, let's do it. Okay, let's do it.
Hello. So, hi everyone. Thank you for being here, and a very big thank you to CityJS for having me here today. So, a little bit more about myself. My name is Tanjin. I'm currently working as a full-time platform engineer at CSIT, and this is actually my first time speaking in a Meetup public setting. So, please bear with me if I sound a little nervous. So, platform engineering work aside, I actually have a keen interest in software development. So on the side, my free time, I actually do tinker quite a number of side projects. And in particular, I think open source projects are always very exciting because these are the kind of projects that have the potential and opportunities for people to come together to solve problems or just build cool stuff. And in fact, it is.
Yeah, keep talking.
And in fact, it is one such project that brought me here today. So how did it all get started? Right? A while back, in fact, sometime in the middle of last year, I was building a couple of websites. So, with AI and LLMs being all the rage these days, chatbots are also kind of like the in thing, And if you are building a website, then having a little chatbot at the bottom to talk to users and engage with users was kind of cool. And I was no exception. I wanted a chatbot for my websites. So I was building my websites in React. There are quite a lot of React people here. And so, back to the slides.
Yeah, just change the slide.
Is it working?
Yeah, I think so.
Okay.
But just put the slide in. Okay, what did I do?
Yeah. So I was building a couple of websites in React, and so naturally I was looking for React libraries to add a chatbot. I found some of them, but that was also when I realized they each came with their own set of problems, right? Just a moment, I need the slides.
Okay, we go.
Yes, so they each came with their own set of problems, right? So I think mainly you have come across this before as well. Some libraries popular at some point, but eventually outdated, no longer maintained, and doesn't really work well on later versions, right? So there are bugs, and it's really hard to get support for them. So not a great choice. Then next, there were some libraries that actually provided a pretty nice basic setup, but if you're looking to do something a little bit more customized, you want some flexibility in how the chatbot looks or what the chatbot can do, you're kind of out of luck because they are not particularly flexible. And lastly, there are also some libraries that were very complicated to set up. So you want to jump into it, but the documentation kind of bring you everywhere. Things are a bit confusing to use and overall very complex. So not a very ideal solution as well. And faced with all these set of problems, I still want my chatbot, right? So that was when I had the idea and motivation to actually try to solve this problem, which eventually led to the creation of React ChatBotify, which is a modern React library for building a flexible and extensible chatbot. And the one sentence there, it pretty much succinctly captures what I was looking for. That was really, I was just looking for a library that was modern, flexible enough for my needs, and I could extend it with whatever feature I want. And throughout the whole time of developing the library, this sentence pretty much was like the guiding principle behind how we wanted to build the library. So, just to give everyone a better idea of what the library is about and what it can do, I'm going to do a very quick live basic setup demo. Okay, so over here, we have the quick start page. So the setup process is incredibly simple, right? Just 3 simple steps and easy to remember. Install, import, initialize. Nothing complicated. I already have a basic React byte set up. Yes, still nice. Okay, nice, great. So I already have a simple byte in React set up. So this was the quick start page I'm talking about. 3 simple steps: install, import, and then initialize. Right, I have a simple web project set up. So I've already installed a library as well to save time. Let's go ahead and do step 2 and 3. So import the chatbot. Let's put it here. Save. I'm just going to go back to the page and take a look. Okay, nice. There's already something appearing at the bottom of the screen. Right, pop it open. It's a default welcome message with a couple of quick start links. So it's to be expected, right? We didn't really tell the chatbot what to say. We kind of just install, import, and drop it in. So this is the default message that we are greeted with. But let's quickly try to make it say something we want it to say. Okay, so there's this part of code I returned and commented out earlier. This is essentially a conversation flow. We'll come back and look at this later. For now, let's just take a look at what happens when we pass in a flow to the chatbot. Right. Okay, nice. Save. Let's go back there. Refresh. Let's take a look again. Oh, the bot is saying something else. So it's asking, who are you? All right. So let's say I'm TJ. It's TJ. Hi TJ, greets me back. Okay, it's a very simple conversation here, nothing complicated. When you look at the code again, it's really just who are you, and then it kind of says hi to me back. So there's a lot more that can be done with this chatbot. And in the interest of time, I can't cover everything, but we can afford to take a look at 2 more examples via the live documentation website, which is here. So going to examples. So we just look at the first one first. It's a live editor, so we can actually edit this. And if you look at the flow here, it's obviously much longer than what we saw in the example. This is an example for basic application form. You can ignore the flow, I'll cover that later. Let's just watch it in action. Okay, so hello there, what's your name? TJ. Nice to meet you, what's your age? 6. Do you own a pet? Yes. At least 2 pets. Dog, maybe. Cat's fine as well. How many days can you work a week? 5. And okay, so that's it. So this is a very simple application form. Kind of asks you for some information, you fill it in, and then at the end, you can kind of do whatever you want with it. Let's look at another example, example. This one is a little bit more interesting. Okay, so it kind of needs your API key, which I'm not going to copy and paste here, should be exposed, but I kind of opened another tab and pasted it beforehand, so it's already masked. So there's a feature for you to mask certain inputs in the chatbot, which is what I'm using here. So I've already provided my API key, and for the record, it's not a good idea to have an API key on client side. It's just for demonstration purposes. Right, so go ahead, we'll send you the key, and it's asking me to provide questions. So let's ask, what is CityJS? Okay, let's wait for response. Oh, it's CityJS is blah 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 blah. Okay, pretty accurate because this is essentially OpenAI's API actually. So we are pretty much talking to ChatGPT. It's not streaming. There's an example for real-time stream as well, which involves Gemini's API. You can play with this on your own, and there are many other more examples here actually. 20+ examples with different use cases. I won't cover all of them, but I hope that these few examples have given you a good idea of what the chatbot is able to do. So moving on next, I want to share how the chatbot was actually designed to support such capabilities. So back to the slides. Okay, so we saw this. So at a very high level, the chatbot itself actually takes in 4 prompts. Flow, conversation flow, themes, styles, and settings. We saw flow earlier, right? In the very first example, we passed in that small block of code. That was the conversation flow. We haven't really seen themes, styles, and settings. We'll look at those later. Let us start with the flow first. Right, so flow is short for conversation flow, and it's essentially the soul of the chatbot, because it's really what defines the interactions between the chatbot and the user. Right, and to help manage flows a bit better, they are actually broken down into smaller things called conversation blocks. So you can think of conversation blocks as small exchanges, which is basically the chatbot says something, user says something, that's one block. And the chatbot says something again, the user says something again, that's another block. So chaining up different blocks together pretty much makes up the entire conversation. It's kind of just exchanges between the chatbot and the user. And within the block, it's kind of cleanly divided into 2 stages. There's the pre-processing stage and the post-processing stage. So pre-processing stage happens while the chatbot is sending its message, and post-processing happens after the user sends the input, and there's some processing going on. So the user input part is where it's kind of like pause between the divide between the pre-processing and the post-processing. That said, there needs to be some way to define the behaviors within a block. So what exactly should the chatbot be saying, or what actions should be allowed or not allowed? For example, should the input be masked, which is what we saw earlier in the OpenAI API key example. And this is when attributes come in. So attributes are within blocks, right? So in here we see the start block. The start block actually has 2 attributes, message and path. Message determines what the chatbot says. Actually, this is the example we saw in the demo earlier, who are you, right? And path determines where to go to next. So that's kind of like the link between blocks. And there's an optional parameter, which we don't see being used in the start block, but we see it being used in the end block. So earlier on, recall that when I said my name was TJ, the chatbot kind of greeted me back. It was actually using the user input parameter. Right? So that was how it kind of knew what I said earlier. And this is really what the whole conversation flow is made up of. If you're not interested in customizing the appearance of a chatbot, you just want to make it say what you want to say, then just knowing this and referencing the API documentation is actually enough to get you up and going with setting up your own chatbot. But most of the time, people do want to start with a chatbot. You want it to feed your website teams, and that's when Teams actually come into play. So Teams is a very new feature in version 2 of the chatbot, and version 2 beta just dropped yesterday. So this is fresh out of the oven. Last minute because it kind of came out in time. So Teams, right? You can tell from the pictures and the name and the term itself that it's pretty much like the skin of your chatbot, how it looks, and also what features it has. So that's what Teams are. And another way to think about it is Teams is essentially a set meal of styles and settings. Styles because it could define the appearance, settings to configure what features will be available with this theme. And I'm going to pause right there and bring you back to earlier on when we saw the slides on the 4 prompts, right? Flow, theme, styles, and settings. So yes, styles and settings are appearing here again, right? And because the themes are very new in version 2. So actually back in version 1, how would you customize the appearance of your chatbot? Pretty much directly through styles and settings. And themes serves as like a layer on top of it, because one of the common complaints was it's very difficult to customize the chatbot from the base template. If you want the chatbot to look very different, there's a lot of customization you need to do to get your own styles and stuff. People were saying it would be great if there were some base templates that you could choose from. And that was how the whole idea of themes came about. If your teams to choose from, they can effectively just pick something that's kind of close to what they want and then just modify a little bit on top of it, which makes it a lot more convenient. But Teams itself introduced a very interesting problem. Because let's think about it, right? If today you were told to introduce Teams, a Teams feature into a chatbot, how would you do it? The naive solution, the first one that came to mind was I will pre-design or just pre-make a couple of themes. I'll edit with the chatbot library and then I'll ship it in the next release. And if the user wants a certain theme, they just specify the theme name, the string, and I just import the styles and settings. That's one way. But it's not great, right? If I do that, then if I want to do bug fixes for teams or I want to release new teams, I need to clone the entire NPM package. The whole library will be upgraded. And if you're just some guy using the chatbot, I'm not very interested in teams. And every time you see version upgrades and you're wondering, is this another team? Do I need to update? Is this a bug fix or is this another team? So not very nice experience. So there was a second solution considered, which is to have a second NPM package. So that way it's kind of clean. You have a core library and then we have another NPM package to install teams. So if users want to use teams, they can install that package as well. That way I can continue to maintain the core library without having to care about whether there will be some teams update that will make it confusing for users. So this is a neater solution, but not the best. I still need to maintain a second package, and if there are 10 teams there, every time that the package gets updated, all the people using teams still need to go and look, is my team affected? Is it my team? Is it not my team? And there's extra setup involved, right? We talk about simple setup. I don't really want users installing a second library just for this. Not the best solution. Maybe there's something better. So the final solution, that one, we went for, is actually quite different from the first two solution. So simply have teams hosted on GitHub. This is very different from the first two things that we were considering. Because think about it, teams, which consists of styles and settings. What are styles and settings? They're effectively just CSS files and JSON files, their configurations. You can actually have them posted somewhere and passed around. You don't necessarily need to create a package just to have them. They don't need to be baked into anything. You can have them posted on GitHub. And so where does all the work go into? The work goes into setting up a GitHub repository in a certain way that allows you to actually do versioning for teams. So there's an overall teams folder, within the teams folder, there are multiple teams, and within each team there are their own versioning folders, and that's where all the files recycle. And you serve them over JS Deliver, a CDN, right? So you don't get really limited by GitHub. And effectively, yes, the amount of changes needed to be done on the core library is so minimal. Because all the core library needs to do now is just fetch teams. It's transparent to users. They just specify a string that identifies the team and then they get a team. They don't even need to install anything, they don't care about how it works. So this has a lot more benefits than the first two solutions, right? So for one, users don't need to install additional installations. Two, I don't need to go and maintain an extra package. And three, what's the third one? Slips my mind, but I'm sure you can think of some benefits for this, right? So yes, but this is effectively how teams are implemented. And there are a lot more interesting problems that I found along the way as I was making this chatbot, right? in the interest of time, if you're interested, we can talk about it offline later. Okay? So I won't be covering styles and settings because styles and settings are really just configurations, nothing fancy. But maybe I can quickly show you how the teams, I will show the teams in action because this gallery website is also just freshly dropped. The bulk of the website is still under construction. The UI is kind of there. I'm looking for contributors. If everyone is looking to do this also. But yeah, this little team builder is supposed to be a preview website, so we could try to pick a couple of things. Let's say I want a minimal midnight team. Oh, nice. So now the chatbot takes on a different look. We can try again, and maybe this time around let's try the sidewalk and terminal team together. So this is how it looks. So
okay.
you can actually stack multiple teams, it's possible. You'll just resolve the teams in order. If the picking styles or little teams takes precedence. So you can technically chain any teams together. I don't know how it will look. There are teams that don't look good together, which for obvious reasons I'm not showing in this talk. There are some very ugly teams if you try to combine them all together. But the overall idea is that it's possible to build a base template team and then have additional teams on it to customize it however you want. There's a team there. So the whole idea is that people can just go to the website, build teams, and share it with others. And others will build the draws and use the teams as well. There's plugins. So there's some to potentially support plugins. The main idea is that in future developers will be able to create their own NPM package that can actually tie into the library for all applications. One of which is the live chat. Because live chat is in times. I think we want to just add a live chat feature directly because it's live chat. And so I want to do this. I think the approach might be a little bit cleaner and run so that some kind of live chat by the own way. And overall, I think it's slightly better solution. Unfortunately, I don't have anything to share for this. It's still a work in progress, but I definitely hope that this will be something I share in future. Right. So I think that's really about it. Yeah, this is very thing. Interested in finding out in general, you can see the QR code. I want a question. Is that data? In
Are you going to use bonnets for this set? Bonnet.
You know what the word is right now?
You're going to find that now. Maybe, but it's a separate bonnet outside. Is this so? I'm promoting this. Okay, so Amanda, she's from Brazil, right? Brazil or Italy? Oh, okay. See, I know everything. So, she's spoken before, but it was online, right? When we did Sao Paulo.
We did Singapore, not Singapore, sorry, India. We did. I've been following you around.
Okay, so we follow her. So, give her a big clap. This is a big follower. And this is the final thing for today. Normally in English, where it works tomorrow. And I'll see you all after this talk, the conference. CityJS code, remember? Okay. I pass it to Amanda, and I will enjoy the talk. I will see your microphone.
Thank you. It's a pleasure. Here, so some people here heard knowledge. I didn't know this talk only is going to know a bit more, but I guess what I can say in general is that we do APIs, do communication APIs. So we'll learn more during this talk. And I think we're on. Thank you very much. Really self-description. I'm with long, long hair, and I'm with the money. My name is Cavallaro. I come from Brazil, but I currently live in the UK, working for Vonage. I do lots of things. I'm actually talking at a Meetup tomorrow, GBG Cloud Singapore. If you have not to do this,
called shops and services. And the demonstration that I have, if you want to check it out by yourself, I have the link here, which is account-recovery-stable. But because just screenshots, I'm not going to go back and forth with text, some screenshots. So, as it says, we're going to see how to recover an account. So, we have here the login form for my bank, and I happen to have a password. What I do is I click the password, and that takes me to a place where I add the phone number that I have with the account. At this point, I'm going to see that says we have detected that the SIM card was swapped. And maybe you did, like I did when I traveled here. I swapped my card, but sometimes you didn't do it. That would be a case of fraud. So if that's the case, you would click. It was me, or it was not me. Hello. Then the first part that would happen, we would use the Vonage Verify API to one-time password, four-digit code, one-time password that you would then sign you into your account. That's the first step. And I'm showing here, this is the amount of lines that you use. I chose the channel SMS, but there's also WhatsApp, there's email, other ones. And then you receive that and click to send verification. And of course, I forgot to say that when we're talking about SIM swap, we use another API in this app. Use the SIM swap API. So after that, you then are prompted to enter a new password that's going to be saved. And with that, when you enter your login details, you can log into your bank account. So I just want to go over the overview directly. So there's the user, you can interact with the front end. You set your password to verify your identity using the front end. I'm using Firebase for this. Is any of you using Firebase? To start, we're using Firebase functions. So I have 4 functions that I'm sending the code, verifying the code, checking the SIM swap. So all of them are being saved in Google, using the Google Cloud functions to the cloud, to these serverless functions. And then I'm storing and retrieving user credentials, everything using the Firebase ParseSmart database. There are 3 databases that you could have used. You know, there's now they just okay, so there's 3 NoSQL databases that you can use. And this is the slide where the user interacts with the front end. So at the same time, in the diagram here, so the user is going to interact with the Vonage communication services using the Vonage API to get the verification one-time code. At the same time, it is checking the SIM swap details with the communication service providers. At the moment, we have 2 providers and 2 countries that have availability. Singapore is not one of them. We have for now Spain and Germany. So we check the SIM swap details with them. They get back to us with the information using our SIM swap API. So this is everything that you saw here. And it's always available for you to check out and see how I've done everything, how to use the APIs just with a single line of code. And so these are 2 APIs. Other things that we do, the top part, we were talking about Chatbots. We also have the Vonage AI that does something similar, but it doesn't focus as much as the front end. We do many things. We can connect to you can use webhooks. We focus more on the back end. Okay, so getting back to this talk, not only talking about the products, but actually let's talk more about the products. So we have SMS, voice, verify, we have two APIs using the network APIs, which is what they install now, and then another recommendation that will become our standards, and really many more to check out. So let's see how we can set up Firebase. For some of you, it's going to be boring because I see that you're already used. So maybe you can help out. I think I forgot to say something. You have to kind of start everything from the console, everything from the CLI. So this page you can go to the console. You go there, you create your project, and one thing which is interesting, once you create the project ID, that's going to change. The name will be changed. I always pay attention to the project ID because when I use Firebase hosting, that's the name that's going to come. So sometimes when it's like we are naming 444 and I can't use it. If you're paying hosting, it's your ID. When you choose, you're going to use Google Analytics with it. I did. After that, that's what you're going to see in the dashboard. That's how we're going to build. So we click on the Firebase database and Firestore database, and we're going to create a new instance. It's called Cloud Firestore. You choose create a database. Again, you could have done that from the CLI. So you choose the location that you're going to use, which is close to you. In my case, it's Europe. Then you choose how you want. Then you're doing this for test. Then once you start information, things you don't want to be able to see production. Use functions to the functions that we talked about. So we use Firebase functions, and functions is a product that can also be seen from the Google Cloud console. So in there, you can see information. This one, if you click on the log to Google Cloud, once you create a Firebase project, that's the same project on the Google Cloud. And sometimes when I'm doing the workshops, I see that people think it's two different things. So they create a project Firebase, and they create another one on Google, and then they so you don't maybe search for the same project ID. To use third-party APIs with Firebase, you have to pay us for Blaze program. But for instance, for this project, I didn't say single. What's the courtesy here? So I talked about this, how I did things on the dashboard. Let's talk about the CLI. So we install the Firebase tools and then we log into the account. Also, sometimes people have different accounts and then they start working on a project, log into a different account, they are logged in. So most of the problems come from have you logged into the correct account? Then you set up your environment. There are two generations of Firebase functions. So this one is for when you're using generation 1, but it's more recommended generation 2. Actually, wrote about 2. Then you initialize Firebase functions. Do the Firebase init and the name of the service. So Firebase init functions. You choose which programming language, which makes sense because I'm speaking at this event. Then you install some dependencies for this. We install the Vonage auth, the Vonage Axios, ports, buttons, and then we set up the Vonage account. Use the two APIs that I talked to you about, the WebRTC and the SimSwap API. And if you want to get started, we are giving out for you to start. Even if you want to try this project or anything else, any of the other APIs that I talked about, you can go ahead. We have this Google code. So if you forgot, you can check it out, but it doesn't last many days. Be quick. So this is how it looks like. Actually, I'll take a picture. I'll just so let you finish. Okay. So this is how it, you can create free accounts, and then you can add those dollars for you to get started and try it out. This is how it looks like. This is application. You have to create a manage application to use with this product. Give it a name, you generate a private key. You should things that you use the verify networking. How to say so? Oh, you have to. Oh, I remember. So this is how the application looks like. And then we add environment variables. One of the dependencies that I talked about is so as you would do normally in your app that you create, you add a temp file and add the environment variable. So the application ID and the Vonage key that you can find from the document before. Then that's what I will talk about. You can also use the GWT that you have to generate a new one for this project. And then the website here I show you, and then you have to add generate it. And then you can also set the number of hours to check the sync swap events. So maybe you want to check if the sync was swapped enough hours ago. You know when you traveled, when you had to change it. You can check when the range that you want to be aligned. And yes, you can use .temp, but there's also something even more stable. You can use the Google Cloud Secrets Manager to enter your secrets as well. And then once you did everything, you can test it out. There's something called emulators. Before I knew it, I was deploying everything, and testing things with deploying is one of the worst things you can do because it takes a long time, takes up a lot of resources. So there is a way that you can test everything locally. And also another thing that I see many errors. People think that when you're emulating locally, you are interacting, for instance, with the Firestore instance that you created on the cloud. That's not the same one. It's going to be one that's running locally. So everything's there. And then once you finish, you on the emulator. You have to go and update the instance, which is in the cloud. So you initialize, and then you start to use it. And then once you've done everything, you want to host a page. There is a product called hosting. For that one, just Firebase deploy. Firebase deploy hosting, yes. And then there's also a new product that was just launched during Google I/O this year. The name is similar to hosting, but it's like app hosting. That sometimes there's Firebase hosting for simple web apps. And then once you've done everything, you can navigate the page. You can do everything that I did before. This is a bit about this talk, but I also about Firebase extension. Has anyone ever used Firebase extension? Actually, Vonage created two, and if you wanted, you could go and create one yourself. So the ones that Vonage has created is create multi-party video calls and Vonage Messages API, which is also cool to play because it kind of guides you. It says, add this API here, add this API there, and then you can see, and it kind of guides you. And you also have some guides written in a recent form and video form if you wanted to try it out and even create yours. And as I've said, I create a lot of content. So if you wanted to see some of the things I've created, if this is inspiring in any way to you, wanted to learn to build this, to build yourself, there's a blog post to improve your multi-factor auth with verified and sync swap API. This one is without Firebase. There's one coming out soon. There is build an appointment scheduler using Node, Firebase, and Vonage. There are 2 videos to send and receive SMS messages with Firebase functions. A blog post that I told you about, that's the title, send SMS messages with cloud functions for Firebase Generation 2. And actually, we have a booth at the event with, on the 25th, 6th. So if you want to come talk to me, to talk to other people from Vonage, I'm losing my voice. Time for you to scan. So if you wanted to come to have a chat and to enter the raffle, it would be a pleasure to have you there. These are the ways that that you can see our content, interact with us, join the community. Thank you very much.
It was fast, wasn't it? Another clap? So, if you ask any questions, you're gonna win some swag. Who wants to go first? Okay, then Melbourne.
Question. Do you guys do email verification as well?
Yes.
Okay,
Yeah.
you get the swag.
So that's of course that slide that I showed you that has SMS. Instead of SMS, you write email and then the email.
What about the template of the email though? Can
The
you put-
template.
Yeah, so the email itself, like the content of the email, not just the code. Is that you guys have the capability of passing in a template or HTML?
Can you create a template for an email?
Yeah, I'm thinking. Oh,
No, we don't do email verification as a product for that, but you can send it yourself.
Right.
We only do communications API, so anything telecom related.
I see.
Okay.
now you can write on your notebook.
I think these two ladies, they want to ask a question. No? Who knows now what is bonus?
You already got it.
Okay, who answered yes, they can get a swag. Do you know what's bonus now?
Yeah.
Yes? Give her a swag. I have to do things, people to get swag these days.
Can you tell the name of one of the bonus products? One of the APIs?
So who has used Firebase? No, you cannot take anything. You used? Okay, oh, you got it, so you can get another one.
Oh yeah, they also have.
Who has used Vue? Okay, he gets one because he used Vue.
Yeah, there was
Who came to CityJS before?
Yeah, they used to do that.
Okay, he gets one. Everybody gets one. Where are you from? Where? Japan. That's my favorite country. You should give him one. Do you know how to make sushi?
I'm sorry?
Do you know how to make sushi?
I don't know, but
Which city of Japan?
Sorry?
Which city of Japan?
Tokyo.
Oh my God, this is my favorite.
Yeah.
And you next to him?
Yes, I'm also from Tokyo.
Tokyo. Great. Give him one as well. You don't know how to make sushi? No. Okonomiyaki?
Yes.
You know? No, you can't get more. Give one to him because he was doing all the technical support.
Of course.
Thank you so much.
Okay, anyone else wants swag? We're gonna have more in the conference, so come there, okay? Thank you.
Thank you guys.